Hey everybody, this is a little impromptu video about an interesting paradox called Gabriel's horn, and it involves the infinite volume of a horn that the angel Gabriel supposedly blew. We're going to look and see whether its volume is finite or infinite. I'm also going to show you how we can look and see about the surface area as well. So y'all know how to find volume of a solid of revolution. So we're going to take pi from 1 to infinity of r squared, so 1 over x squared dx. And so that's our formula for volume of a solid of revolution. We have an improper integral because of the infinity, so I'm going to change this to a limit as b approaches infinity of pi times the integral from 1 to b of x to the negative 2 dx, which gives us what? Negative 1 over x, or negative x to the negative 1. Go ahead and I'm going to put the pi on top. And we're going to integrate or evaluate that from 1 to b. So you get negative pi over b minus a negative pi over 1. And as b goes to infinity, we know that this is going to 0. And so we see that this horn supposedly has a finite volume, which is kind of cool. So let's look at the surface area, which is something that, just due to time, I skipped over. But you can also find the surface area of a solid of revolution. And you kind of know back from the surface area, let's kind of go to a cylinder. So the surface area of a cylinder of radius r and height h is 2 pi rh. So if we look at this as the cylinder, and we start looking at these as little cylinders, as basically this length can be attributed to arc length, and r is y. So we've got 2 pi from 1 to infinity of r, which is our function 1 over x, and h is our arc length. So if we've got the function y equals 1 over x, dy dx is negative 1 over x squared. So our arc length is 1 plus 1 over x to the 4th dx. And that integral, I'll just be real honest with you, is a hot mess. You can integrate it with triangles, but most textbooks or even websites will kind of take a chicken way out of it. So this is definitely a positive quantity. And so what they're saying is that our surface area then is greater than 2 pi from 1 to pi of 1 over x dx. So they just took this part out of it, and we can see that that's going to increase the surface area, so our area is just greater than the simple 1 over x dx. And here again, we've got another improper integral because of the infinity, so I'm going to change it to the limit as b approaches infinity of 2 pi from 1 to b of 1 over x dx. And that integral gives us 2 pi for ln of b, ln of x. Let's hope this doesn't go out on me. From 1 to b, and we have 2 pi ln of b minus ln of 1, which is 0, but b is going to infinity, so the ln of b is also going to infinity. So the paradox here, or lies, is how can we have a finite volume? So basically, if I just started filling this up with something, it would measure out to converge to pi, but the surface area continues to increase. So there's where the paradox lies. I've given you two more examples of an improper integral where infinity is the impropriety. The other types deal with if one of your limits of integration is a vertical asymptote or it passes over a vertical asymptote. And I'm going to turn this off before I lose power. I will see you all either tomorrow or Tuesday. Bye.